Hi, everyone out in YouTube land. Thank you so much for joining us today. As always, I am Yuri Grinstein, your host, and I'm incredibly excited today because for the first time, we have guests in the studio. We have Shirlin and Christoph from Elastic. Please introduce yourselves.
Sure. Thanks, Yuri. Hi, my name is Shirlin Yiu, and I'm from Elastic. I'm on the business development team. So, very happy to be here today. Thanks for having us.
And hey guys, I'm Christoph. I'm a principal solution architect, so I work with all of the users and customers that we have here in the Bay Area.
Awesome. I'm really excited. Thank you so much for taking the time to join us today. I really appreciate it. I imagine a lot of folks on the line have probably heard of Elastic and they know what y'all do, but I think they would also like to hear it from you as well. So, Shirlin, can you tell us a bit about Elastic?
Absolutely. So, as Yuri said, for those who are not familiar with us, here's a little bit of history of Elastic. So, it all started back in 2010 when our CEO, Shai Bannon, he was working in London and he wanted to create a recipe search engine for his wife. Now, at that point in time, there wasn't any great kind of open source text search engine out there. So what did he do? He was like, I'm going to create my own, which he decided to call it Elasticsearch, made it open source and put it on GitHub.
That's brilliant.
Yeah. And then the community picked it up. People really liked it. And at the very beginning, people mostly use it for text search purpose. So the early adopters would be like Wikipedia, Facebook, GitHub, and just on the search engine for a bunch of websites. And then sooner or later, people realize that, hey, Elasticsearch is more than just text search. You can use it for searching through machine data for logs and metrics. I mean, it makes sense because Elasticsearch is really fast, it scales really well, and it has real-time read and write. So it becomes more and more popular, and then we start building tools around it. So say, for example, there is Logstash for ingestion, and there's Kibana for visualization. And that gives us the acronym of LStack,
absolutely.
right? ELK, Elasticsearch, Logstash, and Kibana.
Okay, very cool. Yep. So you just said something that's really interesting. You said that the company started when your founder put some code on GitHub. Obviously, here at Google, we are very much committed to an open source philosophy and supporting the open source community. Is Elastic still open source, or is your code still open source?
Absolutely. So we are at the core open source, but we also built and developed a bunch of other commercial functionalities around it so that, to assist the users and the community out there. For example, there is security, monitoring, alerting, and then machine learning. And Christoph will be showing off a bit of those in a few seconds.
Awesome. That's really cool. I'm actually excited to hear that. And obviously, Elk is something that I hear about a lot. I've worked with a bunch of customers that use Elastic. I've always heard good things about it. Something that I think everyone I've ever talked to has always said good things about it. So
That's
I'm
awesome.
excited to have you all here.
That's great.
Thank you so much for doing this. So maybe at this point, it might make sense for Christoph to kind of take us one level down, kind of show us how to use Elastic, what it can do for folks. And I think one of the things, obviously, that I'm interested in is, how can folks that are on GCP use it?
Yeah, for sure. Do you want to share my screen?
Yeah.
Let's do that. Great. So here we have the Google Cloud Platform Launcher, which most of you will be familiar with. And what you can do is we have several ways of deployment. You can, of course, just download the software. It is open source after all. You can just download it and run it on just GCP instances. But what we also offer is a fully managed service, a hosted service, where we run the software for you. And we're in Google Launcher. So what you can do is you can search for, we call it Elastic Cloud. So if you search for that here, it's going to appear. And then if you click on the link, there's some information here. And then if you click on the link, you get to our website. And the way it looks is like this. So here, basically, in this UI, you specify the cluster size. You have this nice slider here where you can just determine the size of cluster you want. You can choose the GCP region that you want to be in. We have 4 regions available. You can also choose how many availability zones you want to have, depending on kind of the mission criticality of the cluster. You can choose things like versions and various other settings. But then at the end of the day, you simply click create. And within a few minutes, we're going to spin up a new cluster for you. And then we're going to give you the URL that you can use to log in and just do everything that you want to do.
So you actually just showed something really interesting. I've obviously seen a lot of solutions that are available on the Cloud Launcher, but most of them, when you hit that button, what it does is basically deploys stuff on Compute Engine.
Yeah.
Right. So it kind of goes out there and installs the software, and then you're interacting with it using your, typically maybe your private IPs or your public IPs. But it's really just like it's basically an installer.
Yeah.
Whereas what you've just shown us is actually a fully managed service that just happens to use GCP as the backend.
Correct. Yeah. And the backend, of course, we also have GCP instances, but it's GCP instances that we manage, and we just deploy our users and customers clusters on it, and then just manage it on our side and give you the API endpoint to use. So I think it's just much more managed and much more easier to use that way.
Very cool. All right. So now that we have a good idea of how to kind of get started, show us what you can do once you have the cluster.
Yeah, of course. So once you have the cluster set up, like one of the things that you have to do is to get the data. And I'm not going to show that here, but it's relatively simple to do. We integrate with a number of services on GCP as well. So I think the common ones would be something like Google Dataflow or PubSub that we can integrate with to get to receive the data and then store it in Elasticsearch, the data store. And then on top of that, we have what you see here, which is Kibana, the user interface. And there's really several things that you can do here. One of the things I'm showing right here. So one thing that you can do is you can just look at your raw data. So here we have some web logs that we've gathered from our own website, elastic.co, about 6 weeks worth of log data from early 2017. And what we can see here is just the requests over time, as well as the individual requests. And what we could do now is we could drill down into each of them. What I want to show here is some of the things that you can search and filter. So for example, we have a search bar up here, and I can search for example, a city, and we get all of the requests from the city. We've enriched the data as it was coming in. We just got IP addresses, but then you can match the IP address to the city and the country and the continent that it's coming from. And we did that here before we actually persisted the data. And so here I filtered down on just Paris, and so we can see all of the requests that we got from Paris. What we could do is we could further filter down on, for example, a specific URL. And now we see all of the requests from Paris that we're looking at this blog post.
And one of the things I'm actually impressed with already is just this is pretty quick. You started out with something like 14 million rows.
Yeah.
And you just got it down to 14 hits. I mean, it was fast.
Yeah. We try. Like we build a lot of data structures in the background to make it fast, indexes, and then we also take advantage of multiple levels of caching to make sure that especially heavily accessed data is extremely fast. As Shirlin said, like kind of the reason to use Elasticsearch for something is if you need near real-time access to your data, if you need to write huge volumes of data very quickly, but also if you need to access it very quickly. And if you do something like, if you have something like weblogs or your metrics, or if you're doing website search, then fast access to data is essential.
So let me ask you a question, and you can tell me if you think that this answer is perhaps too complex to address here. Obviously, if you're running on GCP, your logging is being generated by Stackdriver.
Yeah.
Is there a simple mechanism to get all those logs into Elasticsearch?
Yeah, there is. So Stackdriver integrates with Google PubSub, and then Google PubSub can feed into Elastic.
Oh, very cool. Yeah, and then so exporting logs to PubSub is something that lots of customers do. Typically, they will often then take them into something like BigQuery from there. Yeah. But sending them to Elastic for the kind of analysis that you've just shown us is, I think, really useful, and it seems like pretty easy to do.
Yeah.
All right, so let's continue.
Yeah, of course. So one more thing that we can do here is that we might want to do is we might want to look at a specific user and just look at what this user has been doing. So let's just pick. I always love doing live demos, so let's just pick a random IP address from here and let's see if it works. So if we
living on the edge,
absolutely. So if we take this one request, then what we can do is let's look at we call the surrounding documents. Let's filter down on just this IP address, and then what we can see is we can see this IP address has requested a certain blog post, and if we go further back, we can see that right before that it was on our downloads page. So currently downloading Elasticsearch. Before that was on our products page for Elasticsearch, and before that on our generic product page. So kind of a normal customer user flow that we can observe here. You could imagine using this for something like root cause analysis, where you have some kind of error message that you're looking for, some kind of exception that you've seen in the log, so that some user has told you about, and you want to see what happened exactly before this error message, what led up to this error message. And this is the kind of view where you would do that, exploring the data.
Yep, absolutely. Makes a lot of sense.
Yeah. Now, exploring the raw data is one way to look at it. And then the other way that you can look at your data is to aggregate, to look at the big picture. And so what we can do is we can build visualizations, and then out of these visualizations we can build dashboards. And, let's look at what that looks like here. So simple visualization is as always the pie chart. Here we can see this pie chart is showing the different HTTP response codes that we see in our weblog. So the majority of response codes are 200, so everything's fine, that's good. But then we also have a kind of a sizable 30% of weblogs that have 404 errors. So people or applications trying to access part of our website that this request failed. And so we might want to explore this a little bit further. What kind of requests were these? Where they're coming from? What IP addresses? What URLs? What resources did these people try to access? And so for that, you probably want a dashboard. And here we have such a dashboard showing a lot of different things. Things like where our requests coming from. We have a map up here, but also how many requests do we have? 14 million. And then various other charts where we break things down by response code, by number of unique IP addresses, number of visitors, by operating system, by browser, and by the resources and the IPs that they're accessing. And actually at the bottom here, we also have the raw requests. So in this dashboard, we can both see the visualizations where we're aggregating, but we can also see the raw requests that both together. Now, what I might want to do here is, because I saw quite a number of 404 errors, I might want to understand better what led to these and what these 404 errors even are. So one thing I can do is I can filter down to just the 404 errors, and I see an interesting thing here where my number of 404 errors over time were relatively constant and relatively low, and then suddenly it spiked. And that might be something interesting to look into.
That was really fast. You were able to filter, and then it actually refreshed every element in the dashboard in what looked like to be less than a second. I mean, that is really impressive performance.
Yeah, thank you. Yeah, definitely. I mean, this is what you need, right? Like this is what you need when you're doing some kind of root cause analysis, some kind of data exploration. You're trying to find out what's happening with your system right now, and so speed is key. So we can see all of the 404 errors here. We have a spike in the 404 errors, and that's something interesting that I want to dive deeper into. And I could now do things like look at the raw requests and maybe filter it on even more. But there's one more thing that I want to show here, and that is how we do anomaly detection. Anomaly detection, or we also call it machine learning, is one of the commercial features that we have for enterprises that use us. And so I just want to quickly show what that looks like. So for that, let's create one of those anomaly detection machine learning jobs. And so what I can do here in this interface is,
so before you create it, can you explain the terminology here?
Yeah.
What is a job in the Elastic ecosystem? Because obviously everyone uses the term jobs, and everyone kind of attaches a different meaning to it.
That's a good point. That's a good point. So a job in that context is when we do anomaly detection, you usually want to do some kind of analysis on your historical data that you have. In this case, we already have 6 weeks worth of data, so we want to analyze these 6 weeks worth of data. And now that is something that we don't necessarily want to do synchronously, but it's something that should happen in the background asynchronously. So that's what we call a job. Now, everything else that we've seen so far, every search that I've done, the filtering, looking at surrounding documents, the dashboard, and the filtering in the dashboard, all of that are synchronous requests, right? Like I've done something, and then I've had to wait a little bit for it to show up. Now, that works when I'm doing these signal requests, but when I'm doing something like anomaly detection on 6 weeks worth of data, then no matter how fast we are, it's going to take some time.
Sure.
And so that's why we need to create a job, and then the job runs in the background to create these anomalies, and then also just keeps running as new data keeps coming in, and just keeps creating, finding these anomalies.
Okay, cool. Thank you. That helps.
Yeah, no, for sure. Thanks for asking. So here in this UI, we can see how we create such a job. What we've tried to do is we've tried to abstract away a lot of the complexities of anomaly detection. It's kind of once we tried internally, or somebody, like one of the developers tried internally to explain to us how the anomaly detection actually works, the math behind it. And well, I'm afraid I didn't understand a lot of it. But what we try to do is we try to abstract away all of the little complexities of it, and just give our users a nice UI, and there's also an API to use it to make it usable for everybody. Now, in this case, I have weblog data. So what I want to look at is, maybe I want to look at the number of visitors on my website. It's kind of an important KPI for every website to track that. And so I can see this from my web logs. What I have to do is let's look at the unique count, the distinct count of IP addresses. And in a second here, we should be seeing just the general up and down that the data like this shows us.
And again, while we're waiting, can you explain kind of what? And obviously, I see that you can click on the little eyes to kind of get an explanation of that particular feature. But what is a bucket span?
Good point. Yeah. So what we need to do is the number of visitors has to be only makes sense in a certain time frame. Like how many visitors have you had in 1 minute or in 5 minutes or in 20 minutes? And so it kind of controls, the bucket span controls the granularity of the analysis.
Got it. Okay. That makes sense.
Yeah. So here we're looking at 15 minutes bucket spans. Now here we can see the data aggregated, and we can already visually see that there's probably some kind of anomaly here in the latter half of the data. Now, if we had a dashboard or visualization that was showing exactly that, this is something that we would probably see visually. But the whole point is of anomaly detection, especially this kind of automated anomaly detection, is to not actually have this, to not actually have somebody looking at these dashboards and visualizations all the time. So the goal of this job is to basically find this anomaly as well as any other anomalies that might exist in here that we haven't, that we don't see visually. Now I don't need to do anything else. I'm just going to give it a name and then create the job. And because this is a relatively simple job, I'm just looking at the number of visitors over time. It's just one metric. It should be relatively quick.
Oh wow! And you can actually watch it work in real time. It's actually showing you the data it's already analyzed.
Yeah. It shows you how it builds the model in real time and how it finds the anomalies. And so it seems that it has actually found the anomaly that we were looking for. Now, what we could do now is one thing that we could do is we could just continue running this job. And any new data that comes in is compared against the model that we built in the background, and then any anomalies being found, we could do something like get an email or an alert of some sort.
Sure.
But let's look at the results here. So if we look at the results, let's look at the very beginning. It's kind of interesting to look at how this anomaly detection works. So if we can see here the first 3 days of data, we didn't really get a good read. The model, the shaded area and background is relatively imprecise. It just has an upper and a lower bound. But then as we kind of go further into the future, we can see how the model tracks the data pretty well.
Yeah. And I mean, generally, that's one of the expectations you'll have with machine learning, right? Is the more data you have, the more analysis you do, the more precise your results are going to be, the better the trained the model is. And over time, your results should get better and better. So
exactly,
that makes a lot of sense.
Yeah. And so we can see here that it has finally found the anomaly that we were looking for. This is real data. So this actually happened to us on this looks like a Monday morning. We had our usual spike in visitors as people come to work and they start working and they're using Elastic. So they're looking at the website for different things. And then we suddenly had a big drop down in our number of visitors here. We can see this visually, but we can also look into the table down here where we can see that we were expecting the typical number of visitors during this time was about 1,450, with about 1,450 visitors, but we actually only hit 86 in this time. So that is 17 times lower than what we were expecting. So it's a very big anomaly, and that's why we mark it red and we give it a very high score.
Yeah. So am I going to spoil it by asking you whether you actually can use this to know what happened, or do you know what happened in
so here we do know what happened. What we did is we have a content management system behind our website like everybody else, and every once in a while we make a change, and usually the change is no problem, like nothing bad happens. But sometimes you make a change that doesn't work out really well. Yeah. So here we made a change that just broke a bunch of links on our website, and so a bunch of people that tried to access things didn't work. But we rolled it back fairly quickly. So like it went back up.
And you can actually tell if you look at the data. I mean, it went right back up. So whoever was on call that day was able to react really quickly and figure it out.
Yeah. Yeah, and that's the value of it, right? Like it tells you really quickly that something bad is happening, something that you might otherwise maybe have missed if you have looked at the data in any other way, and then you can react to it really quickly. And that goes back to like the point about speed. We want to be fast. We're kind of the tool for accessing any kind of data really quickly, especially the ones that like real-time auto-generate data, things like machine data. And yeah, there's different ways, things that you can do with it: search it, filter it, aggregate it, or do anomaly detection on it.
Awesome. Very cool. Well, thank you so much for that demo. That was really informative. I hope folks on the line learned as well. Yeah, if you wanted to kind of tell people like what they should do next, what would you recommend?
Oh yeah, for sure. So yeah, if you want to use Elastic, I think the easiest way to get started with it is to actually use the Google Cloud Launcher that I was showing earlier. I think everybody probably already has a Google Cloud account, so just go in there, just search for Elastic Cloud, and spin up maybe a really small instance just to get started with, get some data and maybe from Stackdriver, and yeah, then see what you get and see what you can do with it.
Yeah, very cool. And I think that was like the kind of second half of what I was going to say is it's really easy to get started, right? Go to the launcher, sign up, and kind of get it rolling. And then from there, like the easiest way to get data into it, which is obviously what you need for an analytics tool like this to be useful, is set up the Stackdriver integration, right? Just start getting logs from GCP flowing via PubSub, and then go into Elastic, and then you can get this stuff, really easily, really quickly.
Yeah,
awesome. Hey, thank you both so much for being here today. We're, as always, really appreciative. Thank you for your time. Thanks for coming in, teaching us about Elastic. To everyone out there, thank you so much for taking the time to tune in. We really appreciate it. As always, like, rate, subscribe, right? That's what the kids on YouTube say these days.
And
yeah, that's right. Lots of likes. And we'll be back on Thursday morning with another customer story. And we've got lots more exciting stuff for you for the rest of the month and hopefully the rest of the year. So thank you so much. Thanks again to Elastic for being here. Thanks for bringing us stickers.
Thank you.
Got a whole pile of stickers on the table. Really appreciate it.
Showcase that.
Thanks for having us.
Thanks for having us. Thanks, everyone.
It's a pleasure. All right, folks. Have a great day.
Bye-bye.
Bye.